topic of this presentation is construction noise and hearing loss prevention. The goal of this module is to provide the necessary training to identify a noise hazard, understand the risk for hearing loss, and know what steps should be taken to work safely to prevent hearing loss. We expect by the end of this presentation, each of you will be able to explain why noise and hearing loss is an important issue for construction workers, recognize the signs and effects of hearing loss and tinnitus, identify hazardous noise, types of noise, and common noise sources, know how to measure noise using common indicators and free mobile applications or apps, describe several ways to control noise exposure, and understand the different types of hearing protection devices used in construction and how to use them correctly. Hearing loss is a big problem. In fact, it is one of the most common work-related illnesses in the United States. And while the numbers vary, according to the National Institute for Occupational Safety and Health, otherwise known as NIOSH, as many as half of construction workers have some job-related hearing problem. Why should you care about hearing loss? Many construction workers lose their hearing at a young age. It is just not a problem for older workers. In fact, construction workers experience hearing loss at a younger age than the general population. According to NIOSH, the average 25-year-old construction worker has the hearing of a 50-year-old person. Too often, construction workers think that too much noise is just part of the job and nothing can be done about it. This is an incorrect view, and that's why it's important to know when noise levels are dangerous and what can be done to control the noise level and protect your hearing. Let's start with how you hear and how loud noises impact your ability to hear. This slide shows the anatomy of the ear. The ear is made up of three basic parts: the outer ear, the middle ear, and the inner ear. Sound travels down the outer ear canal, hits the eardrum, and makes it vibrate, move back and forth. The vibrations pass through the middle ear, which creates motion in the inner ear that is filled with fluid. The movement of fluid in the inner ear, also called the cochlea, bends thousands of delicate, tiny hair-like nerve cells. The movement of these hair cells sends signals to the brain through the auditory nerve. Brain interprets these signals as sound. A video produced by WorkSafe BC once described the hair cells in your ear like grass in a field. When the wind blows, the grass bends and reacts to it. If it is treated too harshly, the grass stem breaks. When grass is cut, it eventually grows back. Unfortunately, your hair cells do not, and that is why hearing loss is permanent and irreversible. Have you ever experienced any of the following? Since you're young, you may not have yet. So let me ask the question another way. Have you ever known anyone who experienced any of the following? Trouble hearing people talk when there is background noise? People sound like they are mumbling? You often have to ask people to repeat what they say? Turn up the radio or TV a lot? Have difficulty hearing people on the phone? Have constant ringing in your ears? These are all symptoms of hearing loss. Hearing loss occurs gradually over time, so you won't notice small changes or loss in your hearing immediately. The last item on the previous slide is a sign of tinnitus. In addition to a ringing sound, tinnitus can sound like a hissing, buzzing, roaring, chirping, or a whistling sound. It is a sign that something is wrong in the auditory system, which includes the ear, the auditory nerve that connects the inner ear to the brain, and the parts of the brain that process sound. Tinnitus can be caused by noise-induced hearing loss and some health conditions, including ear and sinus infections, brain tumors, certain medications, and drugs. The American Tinnitus Association estimates over 50 million Americans experience tinnitus. Of these, 12 million have tinnitus severe enough to seek medical attention, and approximately 2 million people are so debilitated they cannot function at a normal level on a day-to-day basis. Nothing can be done to fix your hearing once it's permanently damaged. But the good news is that noise-induced hearing loss is preventable. When you work in construction, you are exposed to noise created by the work you're doing and noise created by other work on the job site. Being able to hear what's going on around you has a direct impact on your safety and life. Let's do a listening activity that will help us experience what it's like to not be able to hear. Take out your worksheet titled, "Are You Talking to Me?" If you don't have the handout, take out a piece of paper and make a grid that looks like this. I'll give you a minute to get this ready. Now, we're going to go through 5 hearing exercises. There's a column for each on your worksheet. For each one, I'm going to play an audio file. Each audio file has 10 words in it. As you listen, try to write down each word that you can hear in the correct column of your worksheet. Feel free to make a guess. At the end of this exercise, we'll see how many you get correct. Make sure your volume is turned all the way up for this exercise. Let's start with the first audio file. You're going to fill in the first column. As you hear words, write them down in the order that you hear them. Don't wait until the audio ends. Was it easy to make out the words? What level of hearing loss? This audio was an example of severe hearing loss with a man saying 10 words over top background noise from a construction site. Now, let's listen to a second audio file. Write down what you hear in the second column.
Star. Q. Bay. Cat. West. Thin. Farm. High. 3. D.
What level of hearing loss do you think this represents? This audio was an example of mild hearing loss with a man saying 10 words over top construction noise from a construction site. Now, let's listen to the third audio file. Write down what you hear in the third column.
Star. Few. Bathe. Cat. West. Thin. Farm. High. 3.
This audio was an example of no hearing loss with a man saying 10 words over top background noise from a construction site. These last two audio files may be a test of how well you hear away from work. Write down what you hear in the fourth column.
Star. Few. Bathe. Cap. West. Thin. Farm. Pie. 3. Gave.
Was it easier to make out the words? This audio was an example of no hearing loss, with a man saying 10 words with no background noise. Now, let's play the final audio file. Write down what you hear in the final column.
Dust. Stiff. Nest. Van. Camp. Smooth. Knees. Few. Else. Flat.
What level of hearing loss do you think this represents? This audio was an example of moderate hearing loss with a woman saying 10 words with no background noise. Here are the words that were in each audio file. Take a minute to check how you did. I'll wait. Are you surprised by how you did? Experts tell us that in the first stages of hearing loss, it becomes difficult to hear high frequencies. For example, you may have had difficulty hearing or understanding the high-pitched voices of children. People with hearing loss often have difficulty differentiating words that sound alike, especially words that contain S, F, SH, CH, H, TH, T, K, or soft C sounds. The words on the audio files we heard today contained letter combinations that are usually affected by work-induced hearing loss. Being exposed to loud noises and not being able to hear well can have other effects that you might not think about. Hearing loss can interfere with communication on job sites, making it difficult to hear warning signals on the job. Loss of balance increasing the risk for falling. Hearing loss can have a huge effect on social interactions and make people with hearing loss avoid social contact with their community, friends, and family. In addition, excessive noise can increase stress and blood pressure and can lead to nervousness, sleeplessness, and fatigue. The most common cause of hearing loss is exposure to loud noises. This is called noise-induced hearing loss. Other causes include ear-damaging drugs, medications, and chemicals, such as some solvents used in construction. These are called ototoxic drugs and chemicals. Aging. Approximately 1 in 3 people between the ages of 65 and 74 has hearing loss. Hereditary. A head injury. Headphone use. Listening to loud music or noises using headphones, particularly earbuds and AirPods, have been shown to cause some damage to cochlea, which may become permanent. Or a childhood illness, such as an ear infection. Noise-induced hearing loss continues to be one of the most common work-related illnesses in the U.S. It can be caused by a one-time exposure to a loud sound like an explosion, or by repeated exposure to loud sounds over the NIOSH or NIOSH recommended limit of 85 decibels for an extended period of time. The amount of damage done by noise depends mainly on how loud the noise is and how long you are exposed to it. The louder the sound, the shorter the amount of time it takes for noise-induced hearing loss to happen. Does anyone know a way to determine if the noise level is too loud while you're at work or elsewhere? This slide shows only a few easy ways to know if it's too loud. You have to shout to be heard when you're at arm's length, about 2 or 3 feet away from the person you're talking to. You need to turn off the equipment you're using to be heard. You need to move to another location to talk and be heard. You have to turn the sound on your car radio up after the shift. I like to use this homework assignment when I teach classes for construction workers. I tell them the next time they drive to work, turn their radio on to the lowest level where they can hear it without having to strain to listen. I tell them don't change the settings before they get out of the car. Then, after work, see if they need to turn up the sound. If they need to, that's a sign that they've been exposed to hazardous noise levels during the day. You should all try this. When you get up in the morning, turn on Apple Music, Spotify, or Netflix to the lowest volume where you can hear it on a device you won't be using all day. Don't change the volume when you turn it off. At night, see if you can still hear it as well, or if you need to turn it up. The previous slides demonstrated informal ways to measure sound. But how is sound actually measured? It's measured in units of sound pressure levels called decibels, named after Alexander Graham Bell. Using A-weighted sound levels, dBA, the A-weighted sound levels closely match the perception of loudness by the human ear. The decibel scale is a logarithmic scale, meaning that a small increase in dBA numbers represents a huge change. For example, using equipment just 3 decibels lower can cut the noise energy reaching your ears by half. That's why even a small increase or decrease in the noise levels of a piece of equipment, for example, can make a big difference for your hearing. The table in this slide shows the limit set by NIOSH and OSHA, the amount of noise workers can be exposed to on the job by the length of time. As mentioned earlier, the NIOSH recommended exposure limit, or REL, is 85 decibels for an 8-hour day. OSHA's permissible exposure limit, or PEL, for noise is 90 decibels for an 8-hour day. The PEL is the legal limit averaged over an 8-hour day for exposure to workplace noise unless you use special protections or controls. OSHA states if you are exposed to an average of 90 decibels for 8 hours, that feasible administrative and engineering controls must be used, and if these fail to reduce sound levels to the PEL, workers must wear hearing protection devices and be trained on how to properly use them. As this chart shows, the louder a noise is, the last 2 columns, the less time it takes to have been exposed above the NIOSH REL and the OSHA PEL, the first column. While it will vary by trade and type of work, overall, construction workers are exposed to noise levels over the NIOSH REL, the recommended exposure limit, 73% of the time. This slide shows noise levels for common tools compared to the NIOSH REL, normal conversation and a whisper. As you can see, even a hand drill, which can be found on most job sites, produces dangerous noise levels that can damage hearing. One resource you can use to get a rough idea of the noise produced by a given tool is the NIOSH Power Tools database. While it does not have every tool, it has enough to give you a good idea of whether or not the one you are using may be putting your hearing at risk. You can find it at the web address at the bottom of this slide. In addition to the noise generated by individual tools, noise is also generated by tasks that you are doing, that others in your trade are doing, and that other trades are also doing. Some of this noise you or your employer may be able to control, but some you won't be able to. To protect your hearing, you need to think about all of the noise being generated around you. While the simple signs mentioned earlier and the noise levels assigned to specific pieces of equipment may alert you to hazardous noise, the only way to accurately know how much noise you are being exposed to is by monitoring the noise while it's happening. There are different ways to measure noise. Two commonly used methods to monitor noise levels at the workplace are personal or worker sampling using a noise dosimeter and area sampling using a sound level meter. A noise dosimeter is worn by the worker to measure the amount of noise the worker is exposed to during the work shift or sampling period. The dosimeter stays on the worker for a certain sampling period, usually several hours or even the entire workday, and continually monitors the noise. At the end of the sampling period, a readout shows the average noise levels. The newest method to measure exposure is to directly measure the individual's protected exposure with in-ear dosimetry. Integrated into earplugs or earmuffs, an in-ear dosimeter device measures and records the actual amount of noise the worker is exposed to, with and without hearing protection, over their entire work shift. A person has to be trained to use both of these methods. A sound level meter is the basic instrument for measuring noise levels. Any worker can use a sound level meter. Some common uses for sound level meters includes spot checking noise levels in the work area, determining an individual employee's noise levels, and checking an individual noise source, such as a piece of equipment or a task being performed. There are also free sound level meter apps you can put on a smartphone. While not as accurate as the equipment we just discussed, these mobile apps are readily accessible and they keep improving. The new sound level meter app developed by NIOSH for the iPhone is considered very good. In addition to measuring sound levels in the workplace, it includes recommendations to reduce hearing loss. It can be downloaded onto any iPhone. For those with an Android device, NIOSH recommends the Sound Level Meter app. Apps for Android devices vary in accuracy and generally are not as accurate as the iPhone app because the phone manufacturers vary. As a result, the Android apps in particular work better if you install an external microphone on your phone. So far, we've discussed the risk, sources, and how to measure noise. Now we're going to shift to ways to control construction noise. This slide shows the hierarchy of controls specific to noise. The most effective option is to eliminate the noise altogether. This may seem challenging in construction, but research on quieter equipment is moving the industry in that direction. If you can't eliminate the noise source, then the next best option is to look for ways to reduce the noise levels. Engineering controls are considered the most effective because they get rid of the hazard at the source. Example of engineering controls would be low noise equipment, putting barriers or enclosures around noisy equipment such as generators, putting noise suppression devices such as mufflers on equipment, and making sure equipment is well maintained. A recent CPWR study on drills found a significant reduction in noise just by replacing a worn drill bit with a new one. Administrative controls can also help. These are policies and procedures to reduce noise by limiting workers' exposure to it. Examples of administrative controls include putting up signs warning workers that noise within a specific area is hazardous, designating specific areas for performing noisy tasks, such as cutting materials with power tools, and placing loud equipment in locations where the fewest number of workers will be exposed. Although it is your hearing that's at risk, it is your employer's responsibility to take steps to protect you from exposure to dangerous noise levels. Here are some steps that an employer can take to reduce their employees' exposure to dangerous noise levels. Plan. Before the job starts, identify the noisy tasks and equipment, when and where they will be performed, and the actions that will be taken to reduce noise exposures. Each day, do a walk-around inspection to make sure the plan is being implemented. Monitor noise levels. Provide different types of hearing protection. One size or style may not fit all workers. Conduct training on each type of hearing protection provided. Employers can also buy quieter equipment. NIOSH's Buy Quiet program was established to encourage companies to purchase or rent quieter equipment to reduce worker noise exposure, provide information on equipment noise levels so companies can make informed decisions when replacing or renting equipment, and move manufacturers to design quieter equipment by creating a demand for quieter products. While there are many things an employer can do to prevent or reduce noise exposure, when exposed to noise above NIOSH's REL of 85 decibels, you should wear hearing protection. There are several types of hearing protection: foam plugs, reusable earplugs, custom molded plugs, banded or semi-aural, and earmuffs. OSHA requires employers to provide hearing protection at no cost to their employees. There are 7 factors to consider when selecting hearing protection: convenience, comfort, communication needs, hygiene, hearing ability, noise level, and most importantly, the noise reduction needed. Each type of hearing protection has advantages and disadvantages. Foam plugs and earmuffs provide a high level of protection and tend to be readily available, but they need to be used and maintained properly. As noted earlier, care and maintenance of your hearing protection is critical. OSHA requires employers to make sure hearing protection is provided and properly maintained. This slide and the next show the basic care that is needed for hearing protection. Formable foam earplugs should be replaced after each use. Reusable plugs should be cleaned with soap and water and replaced when worn or damaged. Custom plugs should be cleaned with mild soapy water. Remember, your employer should train you on ways to properly care for this equipment, and the manufacturer will also have instructions for their use. And you should ask for new hearing protection if yours is dirty or worn. Banded or semi-aural hearing protection should be cleaned and the pods, the part that goes in your ear, replaced regularly. Earmuffs should be wiped down with a damp cloth, and if the cushions can be removed, they should be cleaned with soapy water. Cushions that are torn or cracked should be replaced. Now that you know they need to be maintained, how do you select the right hearing protection for the noise you are being exposed to? Hearing protection devices are tested in a laboratory to determine how much noise they block from reaching your ears. This is called the Noise Reduction Rating, or NRR. The EPA requires manufacturers to list the NRR on the hearing protection device's packaging. The higher the NRR, the greater the protection. However, since lab conditions are not the same as workplace conditions, the actual noise reduction is at least 7 dBA less than the printed NRR. So if, for example, you select hearing protection with an NRR of 29, you should plan for noise reduction of only 22. As a rule of thumb, you should select hearing protection that has an NRR that is higher than the noise level you are exposed to at work. Here's one way to figure out how much your hearing protection is reducing your exposure. If your hearing protection's NRR is 33, for example, you should subtract 7 from 33 and divide the results by 2. So 33 minus 7 equals 26. 26 divided by 2 equals 13. Subtracting that number from your noise exposure of 95 dBA will let you know that your exposure with this hearing protection is 82. below the NIOSH REL and the OSHA PEL. But as the examples on this slide shows, even if it's the right NRR, if the hearing protection is not used properly, if it does not fit, then it will not work. Even though the second earplug in this picture is inserted into the worker's ear, the earplug is not fitted properly, and it is also worn around the edges, so it doesn't give a good fit. It won't be protective. Since earplugs will not protect your hearing unless they are inserted properly, let's start by watching this short NIOSH video on how to properly use earplugs.
With clean hands, roll the plug with your fingers until it's as thin as you can make it. Reach around the back of your head to pull the top of your ear upward and outward and slide the plug completely in. Hold the plug in place with your finger for about 20 to 30 seconds while it expands to fill your ear canal. Soft foam earplugs will protect your hearing better if you follow the roll, pull, and hold steps.
Now let's review how to insert earplugs correctly. I'll walk you through the steps so you get an idea of the process. First, roll foam plug tightly. Make sure there are no creases. Next, pull your ear back gently at the top to straighten the ear canal. Insert the plug. Release your ear while holding the plug for 20 to 30 seconds. It will expand to the shape of your ear canal. When plug has expanded, tug on it gently to see if it is secure. Then do the other ear using the same process. To check the fit when you're all done, cup your hands firmly over your ears and release. When inserted correctly, the earplug should have blocked enough noise so that covering your ears with your hands resulted in no significant change in noise level. You have a handout titled Steps for Inserting Earplugs that includes the steps for proper use of earplugs and the link to the video we just watched. I'd encourage you to try inserting the earplugs until you're comfortable that you understand how to do it properly. Just to recap, today we covered the risk for hearing loss, sources of noise, how to measure noise levels and control exposures, hearing protection devices, and some real-life lessons. Before we close, I just want to note that many of the materials for this module were adapted from a training program produced by the State Building and Construction Trades Council of California and used with their permission. The Are We Talking to Me audio tapes and exercises were developed by and used with the permission of Dr. Robert M. Gamp and Brad K. Witt of Honeywell Safety Products of San Diego, California. Thank you and be safe.